Welcome to today's Explainer, Class 9. Okay, I want you to just pause for a second. Think about something for me. What is literally right beneath your shoes right now? I mean, sure, it's the floor of your room, or maybe the pavement outside, but what's beneath that? And beneath that? Well, today we're going on this mind-bending journey straight down to the center of our planet. And then, we're going to ride the incredible, never-ending rock cycle all the way back up to the surface. It's going to be awesome.
You know, it's pretty common to just assume our planet is this giant, solid ball of dirt and soil all the way through. But actually, scratch that idea. Let's challenge that right now. Because if you were to somehow magically slice the Earth in half, you wouldn't just find some boring pile of dirt. No way. You'd see something that looks a whole lot more like the layers of an onion. It's constantly moving, shifting, and, believe it or not, even boiling down there.
So here's our quick roadmap for this explainer. We're looking at inside our Earth, then the crust, mantle, and core. After that, rocks versus minerals, the three rock types, the rock cycle, and we'll wrap up with why rocks matter. All right, let's dive right in. Section 1. Inside our Earth. So like we said, our planet is deeply complex and totally dynamic. It's divided into three really distinct, fascinating layers. And just like that onion we just talked about, each layer has its own unique chemical makeup, physical properties, and a crucial role in keeping our whole world spinning.
Okay, here's a really great high-level overview of where we're actually heading. We've got the crust on the outside, the mantle sitting right in the middle, and the core at the absolute center. Now, the main takeaway here is this. As you travel from that outermost crust down to the innermost core, two things are going to increase dramatically: the pressure and the temperature. So let's break these layers down one by one, starting at the top. Section 2. The crust, mantle, and core. We're going to begin our descent right at the very top layer. I mean, this is basically the stage for all of human history, right? It's the layer where we build our houses, grow our food, and basically interact with every single day of our lives.
So this outermost solid layer is part of what we actually call the lithosphere. Now, even though it feels endlessly deep to us when we're digging in the yard, the crust is actually the thinnest layer of the entire Earth. It's kind of like the very thin skin of an apple. And what's wild is that its thickness actually changes. Under massive mountain ranges, it can be, up to 40 to 45 kilometers thick. But out under the deep oceans, the crust gets incredibly thin, sometimes less than just 10 kilometers. Okay guys, here is a fantastic little memory trick for your exams to help you remember exactly what these layers are made of. The continental crust, so the land, is mostly silica and aluminum, so we call it CaL, SiAl. The oceanic crust, that's silica and magnesium, so we call it Sima, Sima. And then way down in the core, it's mostly nickel and iron. Now remember, iron is Fe on the periodic table, so put nickel and iron together and you get knifey. It sounds literally exactly like the word knife, like you're cutting a knife right down to the center of the Earth.
Right, so once we dig past that crest, we hit the mantle. And the depth of the mantle is represented by this truly massive number, 2,900 kilometers. To put that into perspective, that is a staggering distance to go straight down into dense rock. The mantle is just completely immense. It's actually divided into upper and lower sections, basically acting as the really thick middle layer of our, planetary onion. And finally, we reach the core, the absolute innermost layer of the Earth. And get this, the estimated temperature down there is a staggering 55,000 to 60,000 degrees Celsius. I mean, wow. It is a literal sphere of fire and just immense pressure sitting right beneath us. And structurally, it's actually divided into a liquid outer core and a totally solid inner core. Moving on to Section 3, rocks versus minerals. So let's transition our journey all the way back up to the nice, cool, solid crust. Because now we really need to figure out what all this solid ground we stand on all day is actually made of.
So the absolutely crucial point here is understanding the difference between a rock and a mineral. People toss these words around like they mean the exact same thing, but they really don't. Minerals are essentially the pure ingredients. They're naturally occurring substances that have a very specific chemical composition. Think gold, silver, or iron. Rocks, on the other hand, they are the chaotic, natural mixtures made up of those distinct minerals. Basically, a rock is like a giant chocolate chip cookie, and the minerals are the flour, the sugar, and the chocolate chips that go into making it. Section 4. The three rock types. All right, now that we know rocks are basically just collections of minerals, we can actually categorize them into three major families: igneous, sedimentary, and metamorphic. Let's look at how they form. The story of literally all rocks begins with fire. It begins with magma. Magma is that incredibly hot, molten, fiery material bubbling deep inside the Earth. Now, when a volcano erupts, this magma comes shooting to the surface, which is when we start calling it lava. And as that lava cools down and solidifies, it forms our very first category, igneous rocks. These are often referred to as primary rocks because, well, they're the starting point.
Now, what's genuinely fascinating about this is how the exact location of where that cooling happens completely changes the type of rock you end up with. If the magma gets trapped and cools down very, very slowly inside the Earth, it forms what we call intrusive igneous rocks, like the granite you might see on kitchen counters. But if the lava erupts and cools super quickly on the outside of the Earth, it forms extrusive igneous rocks, like basalt. Makes sense, right? Intrusive inside, extrusive outside. But here's the thing. Rocks don't just stay put forever. Wind, water, and weather are constantly beating down on those hard, igneous rocks, breaking them into tiny little fragments called sediments. Then, these sediments wash into rivers and oceans, gently settling at the bottom, layer by layer by layer. Over thousands of years, all these layers get pressed together to form our second type, sedimentary rocks, like sandstone. And because they form in these really gentle layers over time, they often trap the remains of dead plants and animals between them, creating fossils. In fact, this is the only rock type where you're going to find the remains of ancient life.
Finally, we have metamorphic rocks. These are formed when you take an existing igneous or sedimentary rock and just subject it to absolutely extreme heat and pressure from deep down within the Earth. Honestly, it's a lot like the intense pressure you might feel right before a massive exam. That pressure forces you to change and adapt, right? Well, in the Earth, that same kind of intense pressure changes plain old clay into slate, and it literally turns basic limestone into beautiful hard marble.
Section 5. The rock cycle. Okay, so we have our three distinct rock types, but here is perhaps the greatest secret of geology. These rocks are not static. They aren't just sitting there forever. They are actually caught in this massive, eternal loop of creation and destruction. And this brilliantly illustrates what we call the rock cycle. It goes like this. Magma cools into igneous rock. Then weather breaks that down into little sediments. Over time, compaction turns those sediments into sedimentary rock. Next, extreme heat and pressure forge that into metamorphic rock. And eventually, that rock gets pushed so incredibly deep back into the Earth that it melts right back into magma. Boom! The entire process starts all over again. It's wild. The Earth is literally continuously recycling its own crust. Section 6. Why rocks matter. You know, it's really easy to just look at a textbook diagram of the rock cycle and brush it off as some abstract science concept. But I want to anchor all this geology directly into your everyday lives. Because rocks, they aren't just boring stones sitting on the ground. They are quite literally the foundation of human civilization.
Seriously. Without rocks and the minerals trapped inside them, our modern world would just grind to a complete halt. We use them for construction, to build our homes, our bridges, our roads. They provide the iron for the very desk you're probably sitting at in school right now, and the graphite in the pencil you're using to take notes. The wealth of entire nations is often tied to minerals like gold, silver, and diamonds. And absolutely critically, sedimentary rocks provide our energy. We're talking fossil fuels here, like coal, petroleum, and natural gas, the very things that power our trains, cars, and our electricity grids. They are everywhere.
Okay, before we completely wrap up, I just want to drop a quick, incredibly valuable bonus exam tip for all you Class 9 learners tuning in. When you're sitting down for your geography exams, especially when you're explaining complex processes like the rock cycle, always try to write your answers out in structured paragraphs. Try to avoid just throwing down loose bullet points. Trust me, your teachers will really appreciate the logical flow of your explanation, and it's definitely going to help you secure maximum marks. So, as we finish up this explainer today, I want to leave you with one final, kind of mind-bending thought. If this rock cycle is real, if the Earth is constantly churning, breaking down old crust into sediments, melting it back into magma, and then forging entirely new rocks, then are the giant mountains we see outside our windows today really the exact same mountains that dinosaurs walked on millions of years ago? Something to think about, right? Keep wondering, keep exploring, and definitely never stop looking down at the amazing planet right beneath your feet. Thanks for joining me.